Hello and welcome. We are happy that you could join us, and I hope you're having a productive day and not being greatly impacted by all that's occurring around us, including weather and ransomware. So let's just sit back and spend an hour learning about containers and how to protect them. So I'm your host, Charles Collegy, the security analyst for Accelerated Strategies Group. And today's DevOps.com webinar is brought to you by Red Hat, partnered with Anchor. And today I have with me Ed Sue, Cameron Skidmore, who is the Global ISV Partner Solutions Architect at Red Hat, and Paul Navarres, who is a Senior Engineer for Anchor. And they will be speaking on finding the hidden risks in your security software software containers. But before Cameron and Paul and Ed get to present, I have some activities I have to take care of, some housekeeping activities. So guys, you're just going to have to wait a moment before you can talk about the best practices for securing containers in the DevOps process. So first, I want you to note that this webinar is being recorded. So later today, it will be available on demand. You guys will receive an email with the link, but at any time, you can go to devops.com to gain access to this webinar on demand, but also to all of the archived webinars. So take advantage of all those webinars, all that information that we have available. I'm going to spend just a few minutes on the big marker platform we use. It's a little different from some of the other webinar platforms. But on the right-hand side of the screen, you'll see the chat button. So this feature allows everyone online to comment on today's event. So you can say hello to the rest of us. You can communicate in reaching there, and there we go. Let me get that in there. Put down where I'm from and saying hello. So, provide us immediate feedback and comments on what you're hearing. We want to hear from you. Some of the audience would like some insights on your own experiences. But if you have any questions, don't use the chat, but you can use the Q&A tab, which is on the further to the right. And we'll try to answer as many of your submitted questions as possible before the end of today's session. And if we're not able to get to them, I'm sure someone from Red Hat or Anchor will follow up. So lastly, you will see a handouts button. This is where you can download today's presentation deck. Now, one of the most important aspects of these webinars to all of you is that we are awarding 4 $25 Amazon gift cards. So please stay with us till the end to see if you are selected. So now it's time to jump into today's session with Cameron and Paul giving the presentation, but Ed is going to introduce them. And so Ed, it's your reins now.
Thank you, Charles. Really appreciate the intro and some of the housekeeping items. Thank you for attending the webinar, everyone who is here virtually. By way of introduction, my name is Ed Sue, and I'm responsible for the global alliances here at Anchor. And it's my privilege to set the stage for today's webinar. So Anchor is one of Red Hat's advanced technology partners, and we have a focus on security. What we do is that we help our customers accelerate the development of secure and compliant cloud-native applications. So that really is what we do, a quick little snippet. But more importantly, we see these trends in the market, right? There's attacks that are happening. There's ransomware. The software supply chain is in the news everywhere. And in years past, many of these high-profile security breaches were focused on strictly stealing data. But really, as we're moving into a more cloud-native, I would say, environment, or we're looking at digital transformation, the containers are a critical part of that transformation. So in the last year, you've seen things like SolarWinds attacks, Codecov, Hafnium attacks, etc. So these attacks are realized they're getting deeper into the supply chain. That means getting into the source code. And that's really where we have the impact as a partnership. So going to the next slide here, the solution is pretty straightforward, right? Traditionally, we have seen most of the security focused on the right-hand side. But as you can imagine, once you are already in production or your systems are already fully live, those breaches can be incredibly expensive. What we are positioning today is that to move your security to the left. So that is where you find the sweet spot with Anchor. Anchor ties into a number of CI/CD orchestrated platforms, and then we harden those containers and publish them into a Kubernetes orchestrator like OpenShift. So that is really the end goal here, that working together with Red Hat, we can accelerate the hardening of your containers. And of course, mitigate some very costly breaches and mistakes. And so with that said, it is my privilege to introduce the two speakers today. Paul Novarese is one of our senior solution engineers. He has been around the block, an ex-Red Hatter just like myself, so we're very close. We're cut from the same cloth. We believe in open source. We love the innovation that open source provides our customers. So you are in good hands. And then Cameron Skidmore, who is our partner solutions architect. I've had the privilege of working with him as well, really developing the partner motions and figuring out how to tackle these massive problems that we encounter in the enterprise. And with that said, I will hand it over to Cameron, and the floor is yours, my friend.
Awesome, thanks, Ed. Always fun to have some fellow Red Hat family on the line. You know, it's a little bit comforting. Also, shout out to Mike in the RTP and Dave from Tampa Bay. Apparently, I don't know where that is, but must be nice. The agenda today is pretty straightforward. First, we're going to knock out some polling questions, so we're going to have a little bit of fun with that. That's also going to help me and Paul really get a feel for the audience and kind of know where everybody is as far as on your digital transformation journey and with your security in your container environments. I'm going to speak kind of briefly on OpenShift. Maybe it's a review for some of you who already have OpenShift. Maybe it's a bit of a crash course and talk about how we start implementing security at that level. And then I'm going to bridge into the partner ecosystem, which is going to be where Paul kind of steps in and educates us about software supply chain, but also SBOMs and how Anchor technology and OpenShift technology really blend together to create a more complete solution and a quicker, secure one. So with that, let's get rolling with some poll questions. So first, this is very serious, and I want you to pick the only right answer here, which I will not tell you in advance. So Paul may have a different opinion than mine, but I think this is just such a straightforward thing. But go ahead and submit your polling. Let's see how it goes. I think we've all had a little bit of carry out over the last year or two. I know I have, or watching too many YouTube cooking videos. So let's see. Can we throw the results up on the screen? Is that going to be something we do?
So the results cannot be on the screen, Cameron.
Okay.
You have to.
Got
they
it.
have to believe us when we tell them what the results are. So.
Well, okay, that's fair. I'm heartbroken, just so everybody knows, because I'm looking at the results. The winner by far is pizza. The correct answer was Thai food, and it got basically last place. So I had Thai food last night and everything. So not happy with that. Anyways, let's hit on over to the next poll question. This one may be a little bit more technical in nature. So if we could go ahead and throw that one up.
So this is the distribution, Kubernetes distribution that you're using.
So what distribution of Kubernetes are you using right now? This is always a fun one. This also helps me a little bit because I'm more the Kubernetes platform person. Looks like we're getting some results in right now. It's a foot race between vanilla Kubernetes and OpenShift, it looks like. Cloud providers gain steam in the final stretch. And finally, oh wow, it looks like Kubernetes, what's that? A fancy Rubik's Cube or something? It might be the winner in the end. All right, in the last moments, it looks like that has won. So a lot of people newer to Kubernetes apparently, which is great, which is fantastic. I think you're going to get even more out of this webinar. You're in the right place. So fantastic. I think we have one more polling question, and then we'll be off to the actual meat and potatoes of the presentation.
So that is up there, Cameron?
Yep. All right. Results coming in now. So it looks like just from this one, self-managed Jenkins might take it. Some more people submitting right now. We'll wait for you to get that in. Okay, so yeah, it looks like there's a clear winner with a little bit around cloud provider and none. But Paul, looks like self-managed Jenkins was the overwhelming answer in that one, which is really good too. So thanks for doing that. It kind of helps us zone in a little bit more of what to talk about today. I think a lot of people are kind of new to Kubernetes generally, so this might be a good place to start. Again, thanks Ed, thanks Paul for being with me here today. I think a picture is worth 1,000 words, and I think a demo was worth 1,000 pictures. So I think the grand finale here is definitely going to be later on when Paul actually gives us a demo. So make sure you stick around for that. But let me set up what the demo is going to be running on, which is our Red Hat OpenShift environment. So the first thing I want to point out is that OpenShift really is Kubernetes, but it's a lot more than just Kubernetes. So just know that always when you're using OpenShift, your foundation for that is Kubernetes, is the Kubernetes platform. In many ways, OpenShift is a smarter Kubernetes platform because we've streamlined the installation and the upgrade experience, which with the speed at which development on the Kubernetes project is moving is a real headache saver. You can also be up and running with a fully configured Kubernetes cluster in around 15 minutes. And you have everything you need from the monitoring at the cluster level to application and developer services to really start at a sprint when it comes to your Kubernetes journey. Things like Kubernetes updates and security patches and component updates can be deployed with a single click, which is just such a time save in the end. But really, it's not just a time save. It also comes back to why Red Hat created OpenShift in the first place. We want to lower that technical barrier to entry and also automate where we can to help your teams do more with less and driving to the scale that you're looking for more quickly and more securely. There often is this false ultimatum between security and speed, and there doesn't have to be. And I think a lot of what we're going to talk about today is really going to prove that to you. Speaking of scale that's found at Kubernetes is really relying on a foundation of RHEL and CoreOS. This means OpenShift can actually update the underlying operating system and scale at the node level, which is particularly useful when you deploy OpenShift on cloud infrastructure because the entire cluster can scale up and down based on your application needs. So that's a little bit about OpenShift. But let's talk about why we're really here today, which is security on OpenShift. So static security policies and checklists are no longer going to really cut it, and they don't scale for containers in the enterprise. So to really get the business advantages of containers, enterprises need to evolve their approach to security. Security must become a continuous activity and must be considered at every stage of your application and infrastructure lifecycle. So it's really becoming integrated at this point in the infrastructure. Doing this right with planning up front, it really will create a more integrated security solution. And again, the whole point here is it will drive a faster app delivery, which is where all of your ROI for your IT is coming from, how quickly you can deliver the value from your software. Securing containers is a lot like securing any running process. You need to think about security throughout the layers of the solution stack before you deploy and run your containers. You also need to think about security throughout the application and the container lifecycle. And finally, you need to control the security of your containerized apps. Defend your container platform infrastructure, and really the reason we're here today, extend the security of your overall solution by leveraging tools from the broader security ecosystem. And of course, I think Anchor is a wonderful example of how we work with our partners at Red Hat to execute on these focuses. Anchor also plays really well with OpenShift ACS, which can use the information collected by Anchor and fold that into the ACS policy enforcement. So there's all sorts of wonderful interplay between the two technologies. And all that, of course, is being helped along by the Anchor certified operator. And operators are really adding to kind of going back to my central thesis there of why we created OpenShift. They're really going to help you get moving quicker, and it's going to lower that barrier to entry. So our certified operators for OpenShift live in the operator hub, which you can see here. It provides a single place on the internet for developers to publish operators for customers to find and consume curated operators. And these operators meet a certain quality standard, so you can have the confidence that they deliver on what they promise. But you can deploy these operators on any Kubernetes distribution, not just OpenShift. However, we've also integrated Operator Hub into OpenShift, where you can also find fully certified operators from our partners like Anchor that meet a very high bar of quality standards. Anchor can, of course, be found here. And with that operator, you know that you're going to have the full support of both Anchor and Red Hat behind it. Any kind of help you need with that, you're going to get from both of us. And operators are going to help you automate a lot of the management burden with different software that you may have running in your Kubernetes environment. Things like installation and upgrading the different products running in your environment are all going to be automated. And again, our goal here, always coming back to this, is to help you do more with less and to implement automation where we can to help you get going at scale. And then, Paul, I promise I'm almost done going on, but this is like the money slide. This is a little bit overwhelming. I know if you haven't seen it before. And at first glance, it definitely is a little bit overwhelming, but I think it really shows the scope of tackling and executing a true DevSecOps strategy in a Kubernetes-based environment. There's just so many different aspects to hit that no one technology solution alone is going to be the answer. In much the same way DevSecOps itself is about breaking down those IT silos within teams, I think putting together a technology solution that can truly enable the DevSecOps also requires industry teamwork. And I think Anchor and Red Hat have really created an excellent example of that. Paul, really excited now for you to start talking a little bit more about Anchor technology. But before I go any further, do you have anything else you want to add to what I said? Anything about maybe the DevSecOps pipeline we have up on screen right now?
No, yeah, I think this slide really is a great, I mean, it is complicated, right? You're looking at this, there's a million little dots on the screen, but the point is, you know, Anchor Enterprise works, you know, basically hand in hand with OpenShift ACS, right? And together they give you that full spectrum of coverage from beginning of it to end, right? From the first time the developer commit, you know, even before they commit code, when they first start writing code, all the way to production and even beyond that, right? It's not just, we don't just disappear once the application is deployed. We continue to watch it after that, right? So not only can you get alerts from ACS while the application is actually executing, but you can continue to get feedback from Anchor Enterprise if things like vulnerability definitions get updated, a new 0-day is disclosed, right? And you need to know, you know, what's my exposure in production, right? So the two products basically mesh. There's essentially zero overlap, and they just complement each other perfectly.
Mm-hmm. Sound a bit similar, but do very different things in the end.
Yeah, the terminology, I think, still needs to evolve a little bit, right? Because you talk about container security, and it's not just a checkbox, right? There are aspects of it from, when the developers start their code, right? As Ed, that first slide Ed showed, right? We want to give the feedback to the developers as early as possible. And in this slide, that's all the way on the left-hand side, right? They're in their IDE, they can get feedback. They build the image, they can get feedback, right? That's really, our goal is to catch we'll never catch 100% of the problems there, but when the image is actually built is our biggest opportunity to catch the most things.
Yep.
And then you can fix them before you even push the image into a registry, before it goes to QA, right? Where it's the easiest to fix, it's the fastest to fix, it's the cheapest.
Right. Yep.
Right. But that said, right, things do slip through and you will get feedback later, right? We want to minimize that, but when it occurs, you still want to have that feedback loop so you can continue to fix things.
Yeah. Another thing that Ed mentioned at the very beginning with the amount of money that's spent, to me, it was so reminiscent of blaming last cause fallacy. And it's not, and people just don't catch on that even now, like SolarWinds and the executive order that just came out, it really is, the attack is moving left and the security needs to shift left, which is what you guys are here to do. So, yeah, go ahead.
No, I was just going to agree with you 100% there.
Awesome. All right. Paul, you want to take it away, talk a little bit more about Anchor specifically?
Yeah, I'll just a couple of more slides and we'll jump into the demo really here. So one, I mean, this is what people think of when they talk about, the first thing you think of when you hear software supply chain, right? Is I'm building or I'm consuming some software, and that software I consume, it has some components that went into it, right? But the reality is it's really much more complex than that, because each one of those components has its own set of components. And the way these new software supply chain attacks work is, all an attacker has to do is find something wrong with one of these pieces, right? And then it just infects the entire chain all the way down, right? We've seen this. I mean, this week, this Kaseya attack, right, is a real. I've been using SolarWinds as an example for so long because everybody's heard of it. But just this week, I mean, a couple of days ago, I think it was Tuesday, this Kaseya attack. The first level that got infected, it only affected like 60 companies, but then those 60 customers infected another 1,500, right? I mean, it multiplies, right? I mean, this makes it look like a funnel, but it's really actually the opposite. As the components get used wider and wider out in the ecosystem, the number of people getting compromised becomes, enormous really quickly.
Yep.
So, our goal then is to inspect not only what you're building, right, but also inspect all of the components that are going in there, because, the reality is you want to trust your vendor, right? But in the real world, you don't know what they're doing, right? You can trust but verify, right? So we'll go back and look at all of these components as well as the stuff that you're actually building yourself, right? So if you're just a consumer, though, and you're deploying ready-made off-the-shelf software, we can scan that as well and give you the same kind of assurances. So whether you're a consumer or you're a cog in this machine yourself, right, you still have all of this stuff behind you. The iceberg, I mean, you've seen all kind of different metaphors for this, right? Mm-hmm. The iceberg is one that people use a lot where, you consider the tip of the iceberg. I'm circling on my screen, but I'm not sharing my screen. But yeah, you think of your software that you're writing, and then there's all of this other stuff under the surface. So we'll look at all of that with our deep, container inspection. And this is just kind of a simplified view of that earlier slide that we saw, right? Where there's a life cycle from left to right. And, any of these things can sneak into your containers at any stage here. And we'll be inspecting and evaluating continuously as the software moves from a developer's laptop to the production cluster, right? We'll continue to evaluate all along that chain. So before we get into the demo, one thing I want to mention here, the real commonality in supply chain attacks specifically is, people think about these software vulnerabilities when they talk about security and scanning images. This is what they mostly think about, right? But there are a lot of other, vectors for compromise, right? There's Trojan horse malware type software that gets in. We've seen that a lot. You see this a lot with like crypto miner hijacking. Software overrides are things like image typo squatting, right? You want to use Nginx in your project and you fat finger it and type Engine Z, and you get some kind of weird component that you weren't expecting. Or more sophisticated than that would be something like an attacker compromises your build process, and all of a sudden you're pulling Python packages from some compromised repository rather than the one you're expecting. And that's even more insidious because you're actually requesting like NumPy or whatever, and you're getting a compromised version of it, right? Let's see. And then credentials, right? We see this a lot where developers will, during the development process, they're storing access keys, AWS keys, API keys in files, right? And the idea is eventually in production, you want to use something like Kubernetes secrets to store those securely, and inadvertently they get left behind. They end up in the image gets published publicly, and all of a sudden you've got a real big problem, right? This happens, a shocking amount of time, right? And it's all out of just forgetfulness, right? It's not a purposeful attack or anything. There's no maliciousness here on the part of the developers. It just happens.
Right.
We can scan for those things in the images and make sure before you publish anything that these things are not out there, right? So these are just, kind of a real quick summary of some of the big things we'll look for. So I'm going to go ahead and jump into the demo here. Let me see, share screen, and I have to hit this button. I was used to. Okay, so looks like it's loading. There we go. Okay, so I've just got a real simple OpenShift cluster here. I've just deployed. I've got a namespace I've built here, and I've just deployed some real simple images, Nginx, a couple of Alpine, Rel UBI based images, and they're just kind of out here doing stuff. And let me see. I've got. Let's just make sure everything's still running here. Yeah. So I'm going to show Anchor Enterprise here. This is our WebUI. This is my live view of the cluster that I'm monitoring. I'm actually looking at that same namespace, and I see those images, and I've already evaluated them. We'll get into the actual evaluations of these and what that means in just a second. But this is how we keep track of things when they're actually in production. So I can, get live feedback if there are new things and kind of, zero in on vulnerabilities in production and things like that. One other thing to mention, just to plug the product a little bit, I'm going to show everything in our WebUI, but we have 100% API coverage. So everything I'm going to do here can be completely automated. If you're a GitOps shop or whatever, all of this stuff can be 100%, fully automated, and it's good to go. But so we'll go ahead and take a look at one of these images and see, how we expand what we can find in there. So this is a particular image I've built just for the demo, right? It's got some weird problems in here. I'm actually going to start with, when we first analyze an image, we have this thing called the software bill of materials. So when we scan the image as early as possible, right, as soon as it's built, your CI/CD tooling will build the image and then call our API to scan it immediately. And we'll just build a list of facts of this image called a software bill of materials. You may have heard of this. It's gotten a lot of attention in the last month or so. There's been an executive order for the US federal government that software bill of materials will be required in the future for all software products. So you'll be hearing more about it. It's still kind of a lot of the specifics of the standard are still up in the air, but we've been using them internally because they allow us to do that continuous evaluation really quickly. So what this is, how is the image put together? What is it based on? What architecture is it for? How big is it? Does it have a base image that we've seen before, right? In this case, my test image here is based on UBI 8. And then we can look at the contents, and the contents can be things like the actual packages, all the RPMs that are installed in there, all of the files individually, right? And metadata around them, permissions, sizes, checksums, and then the language artifacts, right? Node or Ruby or Python, et cetera, et cetera. And then more importantly, how is this image put together, right? Layer by layer, we're looking at the Docker history here. We can basically infer the Docker file, right? And say, what was the developer doing at each layer? What did they do? You can see here, like all of the stuff I'm putting into this image, right? There's a ton of weird stuff I'm doing. That's the software bill of materials. Then we evaluate that software bill of materials and say, okay, given what's in this image, what vulnerabilities are there? This is done on the fly, right? As we move the image from the development stage to QA to production, this will be continually updated with the latest definitions and say, oh, even though I scanned this image 6 hours ago, I've got the latest definitions 10 minutes ago. What are we seeing in here? This is just a completely matter-of-fact view of the image and saying, okay, these are the vulnerabilities I see. Then on top of that, we do what's called a compliance evaluation. I've got a bunch of rules. We'll look at those in just a second to say what risk I'm willing to accept, essentially, what is in compliance, what is out of compliance. And we'll help you build those rules according to industry standards like NIST 800, 180, NIST 853, the CIS Docker benchmark. There's a ton of these things, right? But what you'll see here is, okay, this image is, you see here, a failing evaluation. Why is it failing? Oh, well, first we got malware in it, right? Oh, it's got a crypto miner in there. Oh, somebody left an AWS access key in there. And we find these are just arbitrary regular expressions. We can really search for anything. We provide a bunch of stuff out of the box, but you can customize these. An SSH private key was also found. Okay, there's a bunch of secrets in there. A vulnerability that didn't meet our criteria, right? So in this case, I think the rule that I have in place is if the vulnerability has a high severity and there's a fix available, we'll stop it, right? But you can tweak all of it. There's 100 knobs you can turn on those, and we'll look at those. More secret scans, licenses, right? I mean, you may have policies, and again, this is way beyond just vulnerabilities, right? You may have internal policies about what open source licenses you will use and which ones you are not allowed to use based on, it could be even vary within a project and say, well, this is an internal project, so we're good with all of this stuff. But for external projects, we've got a stricter list of requirements. We can build rules around those as well. And what those policy rules look like, we put them into what's called a policy bundle. Bundles are just a bunch of rules grouped into policies. We can actually apply different policies to different images, but the things in the software supply chain specifically we would want to look for are first the CVEs, right? And as I mentioned, there's a bunch of knobs we can turn here. We can look at, in addition to just the severity, we can look at CVSS scores. We can look at when an advisory was published, when the fix was made available, anything like that. We can build these really sophisticated rules around. Things like image typo squatting that we mentioned, right? The easiest fix for that is just say, we're not going to allow you to use public images. We're going to force everyone into an internal repo for their base images, or internal registry for their base images, and we're only going to put vetted images in there. And we can even get really specific here. I mean, depending on how strict you want to be, we could even say specific image digests for base images that are approved. And you could even, if you want to go fully automated GitOps, you could update that policy on the fly every time you update your blessed base image and put those image digests into the policy. I mean, again, GitOps automation would make that very easy. Obviously, that would be almost impossible to do manually, like logging into the WebUI and updating it. It's just not scalable. But these new GitOps techniques really do make that kind of attention to detail possible. data transfer checks. These would be things like making sure that developers are not, I think I just deleted something. Whoops, let me re-edit that. Yeah, okay, good. This would be just making sure that developers are not pulling down arbitrary code from, you know, a public GitHub repo or something like that, right? And these are just, again, arbitrary regular expressions. We can make these as complicated or as simple as we want. Dependency confusion. This was another one we mentioned earlier, right? I want to make sure when my Python developers install packages, they're actually pulling from an internal repo of blessed content, right? And they're not using some hijacked repository. And then secret scans, as we mentioned, these, you know, these are just things that we can provide out of the box, these basic regular expressions, and you can expand them to whatever you want. In this case, I've got AWS keys, SSH keys, API keys, but you could put whatever in here. So you get the idea there. And then once these are in place, then it's like, okay, how do we do that automated scanning we were talking about? I'm going to use the example for Jenkins, since most people, you know, answered that if they are using automated CI/CD tooling, they're using Jenkins. And most people that are using something else are at least familiar with Jenkins. Mm-hmm. So in this case, it's a real simple pipeline. I build an image and I push it to a Scratch repo, let's say. And we don't even have to push it in this case, but this is the demo that I have. And then I scan it with the plugin. So our plugin, this just kind of handles hitting our API. And basically what happens is if it gets a failure right there, we can instantly break the pipeline and push feedback to the developer. And if it passes, we'll go ahead and, in this case, I just retag it as production and push it to I'm just promoting it to another registry, essentially. And what this looks like to the developer, right, is just real simple. They'll get that feedback right here in their WebUI without having to go to our interface. And let me just pull it up. And you'll see here, they just get all of that list of vulnerabilities, that list of policy evaluations. Out of our API, it's just JSON data. And then our plugin converts it into a human readable format. And they'll get that same feedback that we saw in the WebUI, right? So they can fix it immediately right here. As soon as their pipeline breaks, they just say, oh, my image failed because I found, this crypto miner, I need to get rid of that. And, oh, the secrets that we found in here, et cetera, right? Mm-hmm. So they can, go ahead and fix that. And then to the final point of, well, what happens in deployment, right? How did this thing get in here, right? I'm deploying these images, and I'll go back to the Kubernetes dashboard in our product. I've got a bunch of failing images here, right? Why are they deployed? Well, that's because, it makes for a more interesting demo, right? In a real production environment, we have our Kubernetes admission controller can actually say, I will not deploy any image into this namespace if its evaluation is failing, right? So we could block all of these. Now, that said, you do always have the situation where something is passing, gets deployed, and then something changes, right? New information comes to light, and a 0-day is disclosed, and you've got that, what was a passing image is now failing in production. So that's where these come in. We can notify you any number of ways through a webhook to Slack, a webhook to a GitHub issue, whatever. And if you want to take that view here, you can just say, okay, show me all the vulnerabilities in namespace X, right? Whoops. So how are we doing on time? That's yeah, we're kind of close there. That's the short view there of end-to-end, analysis, evaluation, and kind of continuous monitoring beyond the deployment. Let me go back to, I think that covers, make sure I didn't skip anything. Yeah, we looked at that. We saw the Jenkins. Yeah, that's it.
A lot of what I'm getting out of what you're showing us and everything, really just the whole idea of software supply chain management and SBOMs and scanning for those. There's a ton of pressure on developers, and mm-hmm. it's unfair in a lot of ways. They're asked to do all these different aspects, and more, I think we're seeing tools like this. It's not that you don't trust the developer, like you said. It's just that there's just so much going on, and it really helps at least in the context of where the software is coming from and what's in the images, put guardrails for them so they can more focus on creating that value that they're trying to create, right? It's less overhead on your part and less worry. And really, when it comes down to it, and I think you and I have talked about this as well, security should also drive not just value in that it's secure, but also speed of creation of applications. And that's what I see this doing a lot of. It lets you go full speed in a lot of ways.
Yeah, I think that's a great point, right? In practice, right, as you iterate your project, right, these scans, I mean, they're not occurring in a vacuum, right? You're building a project, you're iterating on it. You're not going to be starting from zero every time, right? So most in day-to-day operations, you'll be getting kind of limited feedback, right? You'll have a clean scan and then something will change, or you update the project a little bit and a couple of things need to be fixed, right? So you're not going to be completely overwhelmed on a day-to-day basis, right? Once you get a clean image and everything is lined up and in compliance, right? Hopefully you on a day-to-day basis, you just have minor tweaks as things update, as new information comes around, as your vulnerability view becomes more complete, as your policies evolve, right? You'll have to, yes, you will have to make changes, but it will be, right, what you said, it'll be rapidly moving and you'll be able to keep up with it because you'll have confidence in everything else you've done and to say, okay, only these things have changed. This is all I need to worry about right now, today. I can take care of that pretty quickly and get this image back in compliance.
Yeah, absolutely. The other thing that came to mind is that, especially when you called out, it's like a hack a week, right? Around software supply chain vulnerabilities. It's chronic at this point, and it makes international news and affects geopolitics. And we're here doing a webinar on it, so that's kind of awesome. You're really by shifting left, like you guys have said, and by moving that focus, you're really getting ahead of the hack, right? You're getting ahead of where the hack's happening these days. That's where all the focus is headed. So you're moving with the times of the security, and I think that's a really cool notion in and of itself.
Yes, yeah, that's a good point, right? The idea here is if you're doing all of this on a regular basis and you're getting this feedback every time you build an image, right? Your practices are going to be better. Your hygiene will be higher. The idea here is that there's no silver bullet, but this is going to give you a better stance, a better posture, whatever term you want to use, so that you have fewer of these incidents. And when you do have an incident, it's going to be less severe, right? That's the main thing, right? We're never going to be able to say, push this button for 100% security, right?
Right.
That's the dream, right? We're always at war with, whatever it is, whether it's downtime. It used to be downtime, right? Now in this Kubernetes universe, downtime is not the worry. It's really more of a security issue, right? Breaches, data integrity, software supply chain. Those are the real concerns now, right? Not to say that we've completely whipped the idea of downtime or application availability, but day to day, this is much more of front of mind, right? And we just want to provide people the assurance that they've done everything they can reasonably do, right? You still have to get some software out the door, right?
Yeah.
I mean, you could spend forever making sure everything is 100% secure and never ship anything, right? But we want to give you the tools to get the biggest, knock out the low-hanging fruit, right? I mean, there's just certain classes of attack that are done over and over and over again. Right. And there's no excuse for letting that stuff through. And those are the, because they're so repeatable, they're also the easiest to catch. All you have to do is take a couple of steps to due diligence to make sure you're not going to get hit by those, right? Totally automate that every time. And then the more sophisticated attacks, we can provide the tools to detect those as well. And the main thing, again, like I said, it's really about, providing a good posture that is going to put you in the best position to survive the most attacks with the least amount of damage, right? You put a seatbelt on, right? You have anti-lock brakes on your car to prevent accidents from occurring, but you still have accidents, right? And that's where you need a seatbelt. That increases your survivability. Yeah, you don't want to get rid of the seatbelts just because you have anti-lock brakes or vice versa, right? You need both. So that's really the same, going back to that metaphor of ACS and Anchor Enterprise working hand in hand. The two of them just mesh together perfectly and kind of give you that assurances in multiple, defense in depth, layered security, whatever metaphor you want to use.
Right. And even extending on that a little bit more, security is part of your product these days, no matter what you're doing. Like the fact that the people who are coming to your enterprise know that it's secure or trust it to be secure and that it is, that's value out the door right there. That's ROI. What we're seeing with this is that on top of speed of development, like we're saying, right? So you're getting both focused on, which I think is really keen. It's two birds, one stone. And like you say, there's no silver bullet, right? Especially Kubernetes based environments are complex and getting more complex. There's a ton of different things. We saw it earlier in the DevSecOps pipeline. That's just right now. That DevSecOps pipeline for Kubernetes environments, I'm sure will get more complicated over time. So you're going to need multiple industry leaders in technology to take care of it. I wouldn't trust any company that said we got it all. That's a red flag. So I think cooperation is huge here from the industry standpoint.
Yeah, just that classic snake oil, right? I mean, buy this one thing and everything is, puppies and unicorns or and rainbows and whatnot, right?
Yeah. There's no such thing. Don't ever go to a restaurant with 300 menu items. You know what I mean?
Yeah, exactly. There's, master, jack of all trades, master of none, right? That's really our philosophy, right? I mean, we focus on a very narrow component here of image, the image itself, the securing that image, and our goal is to be best in breed of that, and I think we do a pretty good job of it. If I do say so myself, right? But yes, you're right. I mean, this stuff is complicated, and it's impossible to be good at all aspects of everything, right? Mm-hmm. I find it overwhelming. Even when I wander outside of my really narrow area, it's just people are becoming more and more specialized. And it's really hard to be a practitioner and be expert in everything from beginning to end. Mm-hmm. So yeah, we do have to work together. I mean, cooperation is the key to just like anything else.
Yeah, absolutely.
Just real quick, I just wanted to go back. I did have that this is that attack I was mentioning earlier, right? And everyone is a software consumer and a producer, right? I mean, so this is what, July 6th, right? 60 people got hit, but it turned into 1,500. And to that point you made just a minute ago of security being part of your product, right? Mm-hmm. That's where these policy bundles come in, right? There are these industry standards, or like the NIST, the CIS Docker benchmark, the NIST 800, FedRAMP, there's a bunch of different standards out there. But the point is, partners that you want to do business with know about them. And if that kind of gives them that assurance that you are doing something, right? That you are checking, you're following those rules, best practices, et cetera. This is how you demonstrate it to them. So a lot of, as an example, if you take credit cards, right, there is a standard called PCI DSS. Yep. And you will find it hard to do business with banks or whatever if you can't pass a PCI DSS audit.
Right.
So these industry standards are, they're kind of specialized for particular industries, and we can build those policy bundles around each particular one. Right. We've done that for a number of different standards. But the point is, it's not just for your internal assurances; it's for the assurances of who you do business with as well, right? It's gonna open the doors, or you'll find doors that are closed to you if you can't demonstrate this stuff. It doesn't matter how secure the software is. What matters is, can you demonstrate that it's secure, right? Mm-hmm. And this is a good way of doing it.
Yeah, it gets everybody on the same page. Everybody has the same table stakes. You have a common language. You don't have to worry, because the more you work with another company, the more you're extending that security out to whomever you're working with. That's part of what that hack was about. So it's really important that everybody gets up to a certain watermark with everything. And this is a great way to start that.
Exactly. Totally 100% in agreement there. So just to recap really quickly before we wrap up, I just wanted to kind of show one more slide here. I think did I stop sharing? I still see it. wanted to go back to this. I think I just hit the slides button. What happened? Am I sharing my content? I don't know.
I think.
Oh, there it goes. I'm back on the slides. There they are. Okay, yeah. I just wanted to kind of one recap slide here. Best practices. These are just the high points, right? You know, they're really all kind of the same thing. You know, you want to have a workflow that's automated and centralized, and you want to make sure everything goes through that process. Even if it's just software you're consuming, you can still send it through your CI/CD pipeline to make sure it gets scanned properly. Build these images from trusted sources, right? So don't just grab whatever off the, off the internet and expect that it's going to be 100% secure. You want to do your due diligence there, what components you're starting with. Automate everything you can, right? If something is automated, it doesn't get overlooked. It doesn't get forgotten. You don't forget to do it if it's automated. And then again, once you're building from trusted sources, you want to make sure you're deploying trusted images, right? So the basic concepts here: one, automate everything. Two, start with a zero trust, and then make sure you build that trust. Vet everything, right? And automate the vetting when you can. So that's it for me. Appreciate the time.
Yeah, it's been fun, Paul.
We got about a little under 10 minutes to do some questions, so I just want to hit a few of them that come through. And kind of the first question we have is kind of an overview and maybe brings in some of the discussions that we had. And so is DevSecOps just an add-on to DevOps, or is it something completely different?
So I'll take that one. Okay. The idea, so the idea, so there's this idealized view of DevOps, right? And there's probably a little bit different of what's actually practiced in the field. So the idea behind DevOps was to get developers and operations guys on the same team, right? And bring them together and have them in the same room instead of the old view, this traditional legacy model where developers built their product and then they throw it over the wall, and then operations is kind of like on their own to get it, out into production. Bring those guys together. They can iterate faster, fix problems faster, fix problems in production faster, fix problems in development faster, all of that, right? Now, bringing security into that, yes, you're going to have a lot of the same concepts, but the idea here is that the security team is no longer an outside entity, right? The biggest problem even in the DevOps world, right, is the idea that the security team comes in and you don't know what they're going to say. You're not really sure what their ruling is going to be. And if they give you a bad report or whatever, you have to go back to not back to the drawing board, but you have to go way back, fix problems, and go through a bunch of process again. If that security team is integrated into development and operations as well, right, you're getting that feedback, instantly, continuously, and your developers along the way become part of the security team, right? That slide at the very beginning, let's see, of our presentation. I'm going to go back here. There are this many developers, 40 million developers, but there's only 70,000 security researchers. I don't know where these numbers came from, but everybody knows this is correct, right? I mean, a lot more developers than security researchers, right? So we want to empower these guys. We don't want to just say, oh, guess what? You're responsible for security now and you're on your own. Good luck, right? We want to empower these guys with the information, with the tools, so that they can become well-versed in the policies, what makes for a secure image, et cetera, right? I mean, this is going to open up a lot more, ability to find the problems faster and fix them faster, right? When the developers become part of the security team, and vice versa.
And I think a lot of what's driven the evolution toward DevSecOps is, one, Kubernetes and the declarative nature that is around that, and software-based nature of it, and also automation. Just those two things alone have really pushed all the different teams together. I mean, so much of Anchor is security at the developer level, right? I mean, that's that right there. So there's impossible to ignore intersection these days. So I think security, again, I've said this like 3 times, but I'll say it again, also driving the speed of development. it's just such a neat idea in and of itself, is becoming more and more of a table stakes idea.
Yeah, yeah. So we'll get time for one more question. I want to get a question from Mike, and he kind of is curious about your definition of hardening, because you were talking about removing vulnerabilities and finding malware, but he was thinking that hardening is really about removing permissions and tightening access control and authentication. So is there different definitions of hardening, or how do you see it?
Yeah. No, that's a really good question. And that's a little bit, I mean, yes, there are a lot of things that we didn't cover here. I mean, this particular demo was aimed a lot at the supply chain aspects of security. But yes, we can build policy rules around exactly what you're talking about. If you want to make sure, like I want to block sudo from being in my container, or any set UID binaries in my container images, right? We could build policy bundle rules around that. In fact, I think I have a couple of them in here where, so like here, I can build a rule that says if a binary has the set UID bit or the GUID bit, I can block it, right? Those kind of hardening, those are kind of those really fundamental rules, right, around hardening containers. And those are important for sure. Absolutely important, right? Or this one here, like I want to block the container from running as root. That's one of those best practices. These things are definitely important. I mean, it's a real good catch to call that out, right? The demo was really focused on the supply chain aspects, but it's not the only thing, right? It's definitely not limited to these particular types of policies. So yeah, those are super important as well. Absolutely.
All right, great. Cameron, do you have anything to add as we're coming down to the end?
No, I just see one more question in the public chat, so I'm going to send out a message to that person and answer their question, but I know we're out of time. So I'm going to let you do your thing, Charles, and I'm going to answer the question.
All right. All right. Well, thank you, Ed, Cameron, and Paul. This is a great dialogue about OpenShift and how Anchor Enterprise meshed with it to provide a solution that allows for better security throughout the DevSecOps lifecycle. And as you mentioned, there is no silver bullet. You can only do better and try to improve. And so that's really what we're striving for, because there's no, really perfect security. It's a wish, but we can get as far as we can. And I picked up a few useful nuggets, and hopefully everyone else did. So before we close for the day, it's time to announce the winners of the 4 $25 Amazon gift cards. So today's attendees selected are Mike L., Jeff M., Christopher K., and Bruce P. So you will be receiving an email at the email address that you registered for the webinar. If you're like me and have like 7 email addresses, it's hard to keep track of them. So in that email, it will explain how you retrieve the gift. So check your spam folder if you don't receive it. So again, I'm going to have to go through it again. Thank Ed Hsu, Cameron Skidmore, and Paul Novaris, our sponsor, Red Hat, and Anchor, and you, our audience, for taking an hour out of your day to spend with us. Goodbye, and may the fickle finger of fate look favorably upon you.